Hello, my name is Madeline Marrero. I'm from the University of Seville, and today I'm going to talk to you about experiences we have in Spain employing construction cost databases as an instrument for the environmental assessment of construction projects. The main objective of the work I'm presenting today is to assess the cost and the environmental impact of our projects throughout the life cycle, from the design stage up to the impact of construction materials, the transportation, the transformation of the land, the construction, the use and maintenance, and finally deciding if we recover the materials and the building or we demolish it. Then, to assess all this, what we do is we need to quantify, right? And for that, we need a clear definition of all the elements that are part of our construction project. For that, we use classification systems. And then those elements need to be quantified, measured, and from there, having a clear definition of the elements and the quantities, we can have a precise environmental and economical type of budget. That way, we can define benchmarking and then improvements to those projects. In the south of Spain, we have worked for the last 30 years in a classification system that has this like pyramid and structure, where at the base of the pyramid are the market factors, and those are taken into account for the fluctuation of the steel prices or the workforce availability, and then all those costs are transformed into a general classification. That's this base are the basic costs. And basic costs are basically of three natures: are manpower, materials, and construction machinery. And those basic costs can be combined into auxiliary costs. Those are like, for example, the mortar, and then that mortar will be employed in a wall, for example. So that's a work unit. The wall in the building, the partition, or the roof, the foundation, those are work units. And those units are also put together depending on their nature and classified into chapters. And chapters are the elements that are taking place in the project, like beginning from earthworks and then foundation, the structure, and so on. And at the end, when we add all those elements, we have our construction project total costs. This methodology employs numbers and letters for its classification. And what we use here is our letters have to do with typical way we call those materials or machines at the workplace. And this classification um, allows us to identify in each basic auxiliary unit cost its nature and then assess many things from it. For example, here you have a concrete Boreate collector. This belongs to chapter number 4. That's the sewerage system. And here you have all the elements, basic elements, or auxiliary elements that start with an A, of that are needed to get 1 meter of this collector. And here we have the quantities, the cost, and the total amount of that element. This quantification for the control of construction costs can also be employed to quantify environmental impacts. For this, what we have done is each element of our construction cost database is calculated the kilograms or the working hours in order to calculate its impact. Here, for example, we have the carbon footprint or the embodied energy, the construction waste generated, and the packaging of those construction materials. everything that comes out from those basic elements that are part of unit cost. For this information to be available in all the different computer software now in place in Spain, all the sector has come together like 25 years ago, and maybe before that, to have a way of storing the information. And this is our exchange information. That way we can codify the carbon footprint or the embodied energy of an element, or with this type R elements, we can register information about packaging or about construction and demolition waste. Well, then, if we have for every single element in our database their environmental and cost impacts, we can put together everything into the assessment of a project. So then, starting from the information that we normally have in our construction projects, that's the project budget. Then there we also have project quantities and the construction cost database. And from there, we have some indirect and direct costs in those elements. Can we calculate, transform them into basic elements, our manpower, machinery, and materials. And we can obtain the ecological footprint, for example, in terms of pastures, sea, cropland, forest, energy, or built up land that is going to be consumed in that specific project. For example, in a case study of this social housing that was built in Huelva, in Spain, um, here those are multifamily buildings that are ground floor for services and then dwellings on the next 3 levels. And in this project, for example, we have quantified the ecological footprint of each of the elements in the project. And you can see there that structures, as is expected, have a high ecological footprint, and then they also are important in terms of costs of the project. Then there are some elements, for example, the installations that are more significant, their cost, than the ecological footprint of those elements. That way, from all that assessment of all the construction units, we can arrange here what are the elements that are more or less impacting in the construction project. And after identify which elements are the most impacting, we have realized that there are few elements that control the impact. For example, in that project, we decided to change these these are 3 construction costs, and these basic costs. Only changing those 4 elements, we can significantly reduce the impact. Here in green is what we do when we change, for example, the metallic formwork for wooden formwork, or the concrete slab to a waffle slab, or we use instead of ceramic tiles, a wooden floor. Then we can see how those impacts are reduced. And then in blue is what happens when we recycle on site some of the waste and employ it as a substitute of some of the materials in those chapters of the project. And we can reach with this leader elements a significant reduction up to 30% of a reduction of the ecological footprint of the project. Also, if we compare our project with others, we have also analyzed 92 construction projects in Andalusia. These are our dwellings, social dwelling. And in here you can see that single family are the ones, single family buildings are the ones with the highest impact, and then up to 3 floors then is stable. The impact per meter square meter of floor, it remains basically constant. Then if we do that for all the life cycle, so our strategy has been, then let's define more units, basic cost and unit cost of future projects that will take place in that building after the construction. For example, what happens when it is 50 years old, what elements need to be replaced when it is 75. We define some other elements using the same classification: basic units, auxiliary units, and the quantities that are defined in the original construction project. So then we have connected all the life cycle through its original budget. And for this, for example, calculating the life cycle of the building, we have, for example, here the water footprint. The first thing is to identify the water footprint of per kilogram of the construction materials. Here you can see that the copper pipe is the one that has the highest footprint. And from there, we can calculate every step of the project, of the life cycle, each stage. And here you can see in terms of water footprint that the use stage, of course, the water consumed in the use of those dwellings is the one that has the highest impact. But then there are also significant the water footprint of the construction stage or the water footprint of maintaining or keeping in good shape that building. So that way, employing those budgets, we can do a projection on what the impacts will be through the life cycle. Here in the next graph, we can see that the structure, this is that same work that we have done for dwellings, we are doing it now for industrial buildings as part of Erasmus Plus project recovering. And here you can see that for our industrial buildings, the main elements are, again, the structural elements are the ones that have the highest here water footprint. And then we can see that also the carbon footprint is important of those elements. And we keep working on this, and we are right now developing a tool for the assessment of these impacts. And the tool is will be available next autumn for the assessment of the life cycle of the buildings. The main references employed in this work are, of course, the publication of our construction cost database under classification methods. And there are also some papers in the group. The main one, when we started all this, was in 2010. And then we keep probably some main also definitions or our model were from 2013, 2009, when we started to do the construction cost assessment combined with the calculation of the environmental impact. So thank you very much for your attention.